Hello again, everybody. This time we're going to take a look at a problem that was found on page 4 of the test review packet. This is number 5. And here we want to find the equation of a line in slope-intercept form, and it passes through this point and this point. Now, if you didn't catch the video before this and you're still having some trouble when I give you a slope in a point, I would check that one out first, and then check this one out second. But if you're ready for it, let's dive into this one. Well, here we want to find our slope-intercept form, and our slope-intercept form, that's a big key factor here. We know that that's going to be a y equals mx plus b form. That's our goal, our end goal there, and we need to figure out what our m is and what our b is to get there. And our key bits of information is we have this point here, and we have this point here. So there's kind of two steps when you're given points. Rather than a slope and a point. So I would say, or two parts I would say. So part one is to find slope. Let's try that again. Part one is to find slope. And our part two is to find the equation of the line. So once we have the slope, then we can plug stuff in like we did for that last problem. So first, let's find our slope. Now the slope is always going to be in the form change of y over change of x, change in y over change of x. And the formula, in case you forgot it, is going to look like this. y2 minus y1 over x2 minus x1. So it's important to identify from these 2 points which is your first point and which point is your second point. So you're taking a look at your x's here, and you're looking at which x is bigger. That's going to be your second point. So this is my second point, so that's going to be x2 and y2 here, and this is going to be my x1 and y1 there. So using this formula, that means that I'm going to have a y2, which is 4, minus y1, which is negative 2. Don't drop those signs. And then I'm going to have my x2, which is 3, minus my x1, which is negative 1. All right, so when I'm subtracting a negative, that's like I'm adding a positive. So I'm going to slip those positives in there. That's all legal to do. And this is going to equal 4 plus 2, which is 6, over 3 plus 1, which is 4. Simplify that out. You're going to get 3 halves as my slope. Hooray! Part 1, done. Okay, so part 2 then is we're going to find the actual equation of the line. So let's scroll down here, give myself some more room to work. I have my m, and I'm going to need to sub in what I know. Take all of my knowns. I have my slope equals 3 halves, and I have an xy coordinate. Let's try that again. An xy coordinate, which is, let's see, what was it back on the top? Let's do the negative 1, negative 2. Negative 1, negative 2. So I just lifted that coordinate right here. Could I have used this 3, 4? Sure, why not? They both fall on that line, so they both are solution sets to this equation of the line. But what I'm interested in is finding now the final equation. So I'm going to have to take my knowns, which is my slope, my m, and an x and a y value, and I got to plug it all in. So I'm going to take my y, negative 2, equals m, 3 halves, times x, negative 1, plus b. All right, this is my y equals mx plus b form. All I did was I subbed in my m, my x, and my y. Now I'm just solving for b. So I'm going to get a negative 2. No, let's try a different color. Negative 2 equals, now 3 halves times negative 1 is a negative 3 halves plus b. I'm going to have to extend the page. I'm going to have to add 3 halves to both sides. Okay, or you could think of that as adding 1.5 to both sides. And so now what I'm going to get left is I'm thinking a 1/2 equals b. If you don't believe me, check. So now that I have my b, I have my m already, that's this. Those are the two things I need for slope-intercept form. So my final equation is going to be y equals, what did I say, 3/2 x plus 1/2. My y equals mx plus b form. And we did it. If you want to see all the work put together, I put it in the description down below, so that's for you.